Okay, today we're going to review a couple of the things we've seen so far on the course, and then I'll introduce the idea of optimization problems. I'd like to start off with some derivatives. Now, these three questions, I've derived these questions from a past paper exam, the hardest derivative I have seen on this course. Okay, a couple of years ago, one of the paper 2 papers. It was quite challenging. And it looked like this. So I'd like to have a go at these ones. Now, what you need to do for this question is you can't differentiate the function when it's in this form. It has to look like a sum of terms. Whenever you do a derivative, you can only do it if it looks like a sum of terms. So here we have a product outside that bracket, and you have to get rid of that. It's like when you have something in the denominator, an x, you've got to get rid of that as well. So it looks like a sum of terms. So your first step in all of these is to expand the bracket using the distributive property. Expand the bracket, then you'll get a sum of 2 or 3 terms, and then you can derive it. So it'll take a little bit longer. I'm going to pause the video for you, come around and help you. Okay, so first up, we need to expand into a sum of terms. And if we do the expansion here of this first one, we get x to the 4 over 4 minus x squared plus 2x squared. I'll write it like this, over x squared. But we can see that these two terms can cancel each other like this. And this will become x to the 4 over 4 minus x squared plus 2. So now, show that we're introducing the derivative concept. All of those terms on the top, they're the function. All of these ones are going to be the derivative. So the derivative of the first one is just going to be 4x to the 3. Ignore the constant in the bottom for now. And then the 2 at the end is a constant which derives to 0. Now simplify your fraction here. And this is x cubed minus 2x.
Do you have to simplify?
Yes. So the same again. Here on the second one, the x squared is going to multiply into all of the numerators. The 2 is going to multiply into all of the denominators. So we get ax squared over 2x for the first term. The second term is going to be x to the 5 over 2 times 3, 6. We can do some simplification here. This x here will cancel the 2 there. And that's going to give us a half ax minus x to the 5 over 6. You can write it like this as a half a, or you can write it as a over 2, or you can write it as ax over 2, all the same, all equal. Now we differentiate and treat this a like a constant, so we're just going to get a half a from that first one. Treat it like a constant because it is a constant. The next term we're going to get minus 5x to the 4 all over 6. If you prefer to see it in fractions, that would be a half a minus 5 over 6x to the 4. These are equivalent statements. Neither is better than the other. The last one, so we're going to multiply the 1 into the numerators, the x into the denominators. That'll give us x cubed over 2x plus 5 over x minus k over x squared. We'll do some simplification. We can see that this x and that 3 cancel each other. And I'm going to do one more simplification as well. I'm going to convert the 2 rational terms into, and move the exponent up and use negative.
Why does the x cancel?
It doesn't cancel all of the 3. It cancels part of the 3, leaving a 2. We're just going to cancel a little bit, rearrange it, and write these with negative exponents. So we get x squared over 2 plus 5x to the minus 1 minus kx to the negative 2. Put it into exponent. Now we'll find the derivatives. This first one is going to give us 2x over 2. This next one is going to give us minus 5x to the minus 2. This last one will give us plus 2k x to the minus 3. I'm doing it in exponent form. Often you'll see me, I'll do these in one step. As this is a little bit long and more complicated, I'm doing it in exponent form, so I get the sign right. This little sign in front of the 5 and in front of the 2k, that's where you can make most errors with this type of one, just forgetting something really simple like that.
Can we simplify?
Sorry,
Okay.
Can you explain how it's changed to half Oh, wait, never mind. Okay. And then you derive that, where does x go?
When you derive a term that's just linear, an x, the x disappears and you're left with just a constant. Right, come on.
Can we simplify the?
Yep, I'm going to simplify now. I'm not there. So these two cancel. And we're going to get x. We'll rewrite this one in exponent, not in exponent form. This will be over x squared plus 2k x over 3. That last one is as hard as you'll ever get on this course. I haven't seen anything quite that hard. It's a little bit easier.
On your test, will you get questions?
B is about the hardest I've seen on an exam. On your maiden next week, no. I said not. I said I'm going to try and make this one.
So for the second last part, why is it like 2kx? No, I'm saying 2kx, you have to power to negative 2.
Here at this point, so let me just point. So it's this term that we're deriving. So we do minus 2 times negative k will give plus 2k.
Yeah, but why is negative 2?
And then x to the minus 2 becomes x to the minus 3. We take 1 away. We're subtracting 1. If you remember the formula is the derivative of ax to the n is equal to a n x to the n minus 1. This is the power rule. So whatever the exponent is, you take 1 away from it. So minus 2 minus 1 gives minus 3.
Oh, yeah.
Okay? All right. Have a go at this question now. Use your calculator. Obviously, you can't separate this into a sum of terms because the denominator is a polynomial expression like this one. So we can't separate this into a sum of terms. We can't simplify it. You must numerically solve using your calculator. So let's see if we can do that in under 2 minutes. Be quick. Be quick. Be quick. Okay. Right, I'll do it now.
Sorry, I already did this calculation, but I think my issue was like I tried to move the number from the denominator up like for the bigger equation. Is that what I think of the times?
That's an error.
If I can't like cancel out the inside and exam question, just end up canceling out the denominator.
Yeah,
I
it's
can't do
a-
that and I move nothing.
You can't move a number from the denominator. You can only move a variable from the up and down by negative. And you make the exponent negative. You make the number negative. That's
I kind of follow the same logic.
no, you're not, because you're not adding a negative exponent. You're adding a negative in front. So you're saying that a half is equal to minus 2.
Yes,
A half is equal to 2 to the minus 1. Not 2 to the minus 1 is not negative 2. Okay, let's have a look at our answer here on this one. This is a quick, easy question. Pull up our calculator. Give myself a nice fresh one. One, new, don't save. Give me a calculator. I'm just going to go straight in because this isn't a multi-part question. So I'm not going to go and graph it and then use the variable thing that I often do for that. It's a single question. So I'm only going to need this term once. I'll just go straight into it. Menu, calculus, numerical derivative at a point. The value we're putting in is 2.3. And then here I control divide 2x minus x squared. Oh no, I'm writing in the wrong place. All going drastically wrong. Okay, 2x minus x squared over 3 minus x. That's that q. I don't know where that one came up. My chubby fingers. Oh. All right. Okay. Just start again. The world is against me this morning. Okay, so what's the answer here? This implies 5.12 minus 5.12. Okay. Have a go at this question. This is typical of what you'll get on the exam next week. Okay, so part A is a standard procedure. It's fairly easy. You've got a function f of x. You have to find the derivative. So the derivative is going to be 3x squared over 3 plus 4x minus 8. And then we'll simplify this term here at the front. And we get x squared plus 4x minus 8. Next, part 2 is a problem solving question. Typically you'll get something not quite worded in the same way as what you've seen before. Line 2 lies parallel to line 1. So line 1 is given here. Line 1 and line 2 are parallel. What does the word parallel mean? What does this word mean, parallel? So, they look like this. Is there any concept that we can relate to that? Any concept, Adam?
Same slope, different line.
Same slope. They're going to have the same slope. So what is the slope of line 1? No. You must rearrange it into slope-intercept form. It's in general form at the moment. So for B, you've got line 1 is 8x plus y is equal to 0. That implies if we rearrange it into slope-intercept form, we get this. This implies the gradient is equal to minus 8. So here is the slope. We know that the slopes are parallel. So line 2 lies parallel to line 1, and both of these are tangents to the curve. So next up, our next concept. Tangent to the curve. What does that tell us? What does that tell us? The derivative at the point we're interested in is going to be minus 8. So the derivative, the point we're interested in is going to be minus 8. So the fact that it's tangent to the curve means that f dash of x is going to equal minus 8. Now we just found the derivative. So this implies that minus 8 is equal to x squared plus 4x minus 8. Do we want to solve that one or simplify it first? There's an easy simplification, isn't there? What's the easy simplification? Well, just to save time, do we really need these two? So we can end solve this at this point, or you can factor it. It's fairly easy to factor. Let's end solve that. Algebra, end solve. We've now got 0 is equal to x squared plus 4x, comma, solve for the variable x. 0 is the answer. 0 is the answer. Now, line 1 is drawn here. What is the x coordinate of line 1? 0. So this isn't the answer. There must be a second answer. So whenever you're using end solve and you get an answer, you need to go looking for other answers. We can estimate where the line is going to be. So let's estimate where our tangent is going to be. It needs to be parallel to that line. So if it's going to be parallel to that line, could it be in this space here, parallel and still tangent?
Yes.
Absolutely not. It can't tangent the curve over there and still look like that. It can't do it here either. It's got to be somewhere around about there-ish. So visually, we can see that it's gonna be around about there-ish, that we can get a line that's parallel, that still tangents the curve. So up there at that point. So our answer, we can see in the diagram, has to be about here-ish. Is that positive or negative? Negative. Which means when we end solve, we don't want to go looking comma 0.1. We don't want to go looking positive answers like this, because you'll get no solution found. You need to go looking negative. So your lower limit, let's try minus 100, and your upper limit, let's try minus 0.1. So look in this interval here, and we find our other solution at minus 4. We can find our other solution. So this equation implies that x equals 0 or minus 4. L1 is at x equal to 0, which implies L2 is at x equal to negative 4. Okay, let's move on. So that's a bit of revision, prepare us for the major next week. Our new concept for today is the optimization method. We'll do a couple of lessons on this one. We'll do this lesson and next lesson. So the optimization method is here. This is what you want to copy down. All right, so this is the optimization method. Your first step typically in one of these questions is to find the equation of what you're trying to optimize. So if it's a profit function that you're making, you have to find the profit, the maximum profit or minimum profit. Often it's volume or surface area. And typically it's both. They'll ask for they'll say the volume is this, find the maximum or minimum surface area. So with that, you'll end up with depending on the shape, you'll end up with two variables, radius and height or something. And you have to eliminate one of them for slightly harder questions. We'll get onto those next semester, next year. So first up is find the equation, then differentiate it. Next, find these turning points, the stationary points. This is where the derivative is equal to 0. Then you have to find out the nature of the stationary points. Is it a maximum or a minimum? Show the sign values of the derivative either side of the points that you locate. Lastly, reread the question, make sure you're answering the correct question, and give your conclusion. So we are going to try a question now. I'm going to do it for you. A can of dog food contains 500 centimeters cubed of food. The manufacturer wants to receive maximum profits by making sure that the surface area of the can has optimal dimensions. Let the radius of the can be r and the height be h. Find the dimensions of the surface area. So step 1, find the equation. Let's see what equations we've got for this one. So we've got a can of dog food. What shape is a can of dog food?
Cylinder.
It's a cylinder. So find your formula sheet. Find my formula sheet. Here's the formula booklet. We want topic 3. Volume of a cylinder here. Area of the curved surface area of this bit. So we are going to need 2 or 3. We are going to need 2 or 3 formulas. We're going to need volume of a cylinder, this one. We're going to need area of the curved surface area of the cylinder. But this one, when you take a cylinder, the curved surface area of the cylinder is this bit. It is not giving you this bit. The red part of the cylinder is what shape?
Circle.
So you're going to need this one too. These formulas are the ones that we're going to need. So starting with the volume is pi r squared h. So we need volume equals pi r squared h. We got 3 variables there. Do we have any numbers for any of those 3 variables?
The volume is 500.
The volume is 500. So 500 is equal to pi r squared h. That's all the numbers that we have so far. We are after the radius and the height. So these are unknown to us. How do we solve this? We can't. So we go back to our formula sheet. Let's build a formula for the surface area. So that's just 2 pi r h. So the surface area is 2 pi r h plus 2 circles. What's the formula for a circle? Pi r squared. So 2 pi r squared. This is 2 circles plus the curved surface area. So step 1 of the method. We found the equations, but we need to eliminate all but one variable. We need to eliminate all but one variable. We have 2 variables. What are the 2 variables we have? We have r and h. We need to get rid of one of them. So we're going to use this first equation. This is typical of these type of questions, to eliminate h. I can rearrange this one to say h is equal to pi r squared, 500 divided by pi r squared. If I take the pi r squared here and divide it down, I rearrange to this. So now I can take the surface area and eliminate h. Wherever I have an h, I'm going to put that in. So I get 2 pi r 500 over pi r squared plus 2 pi r squared. This will give me 2. I'm just going to put this at the front. 2 pi r squared plus 2. So this r here can cancel that squared there. 2 times 500 is how much? So we have 1,000 pi all over pi r. Can we do any more simplification of this? Cancel out the pi. And then we can rewrite this now as 2 pi r squared plus 1,000 over r. This we can derive. So now we have a function which describes the surface area in terms of the radius only. That will vary. This function will go up and down, or actually go down and up. So we need to, we've done step one. We've done step one of this. We're on to step two. Differentiate. So this is step one. This is step two. What is the derivative? Four pi r. What is the derivative of the second term? If we derive it, I'm doing it in one step this time. If you rearrange it, it would be 1,000 r to the minus 1. If you derive that, it would be minus 1,000 r squared. You should be able to derive terms like this in one step. One step. So this is the derivative. In order to find stationary points, step 3. In order to find the stationary points, we need to set the derivative equal to 0. So 0 is equal to 4 pi r minus 1,000 over r squared. I'm going to solve this algebraically a little bit. So if I multiply both sides by r squared and divide by 4 pi, I get 1,000 over 4 pi is equal to r squared. Sorry, r cubed. Be fine. It will be fine to use that solve. No, I've rearranged. So this tells me that r is equal to the cube root of, well, 1,000 divided by 4. Is that 250? 1,000 divided by 4? So you need to not give up at this point. It is challenging. Don't just give up and go, I'm shutting down. I can see half of you shutting down. Can't do this. So this is 250 over pi. Put that into my calculator. Let me just do it on the calculator so that people can see me doing it. So this is going to be 250, 250 over pi. Enter. 4.3. 4.30. 4.30. This is 4.30. Maria, you said, can we end solve it? Yeah, we can. So let's end solve it right at the first point. So we don't get it wrong. So we can end solve it at this point. So end solving at that point. Menu, algebra, end solve. 0 is equal to 4 pi r minus 1000 over r squared. Solve for the letter r. Get your calculators in your hand. I'll go for one more trick. Here in red, we have the original function, don't we? To find the maximum and minimum points, we need to differentiate that and then solve when it's equal to 0. You can do that in one step on your calculator. You can get the calculator to both differentiate it and solve for 0. Let's try that for one step. It's a little bit more complicated, but if you're good with computers, you should be able to follow this one along. So we want to solve, so we'll start off with our end solve. We want to solve for when the derivative is equal to 0. So 0 equals the derivative. To find the derivative, we can use the templates button. Press the templates button, choose the derivative. So we want to differentiate with respect to r. We want to differentiate the term 2 pi r squared plus 1000 over r. We want to differentiate this expression with respect to r, then set it equal to 0, then solve the equation, comma, for the variable r. Okay.
So this is to find the derivative and solve.
This is to find the radius. Let's go back to our question. So we've done parts 1, 2, and 3. We now need to investigate the nature of the stationary point and show whether this is a minimum or a maximum. We can do this in numerous ways. So is this r value going to give us a minimum or a maximum? Well, what is the derivative function? 4 pi r minus 1000 over this. So let me take my calculator. Let me add a graph page. I'm going to type in the derivative, 4 pi x minus 1000 over x squared. This is a bit too much of a vertical line to see which way it's sloping. So I'm just going to go here. So I've typed in the function. So function 1 is the derivative. I need a value either side of it. So our sine table will look like this. These are the x values I'm going to use. And this is the value of the derivative. What was the x value when the derivative was 0? What was the x value when the derivative was 0? 4.30. Ask yourself, why didn't you know it was 4.30? This is all that we've been doing here in this question is to find where the derivative was equal to 0. Our answer was 4.30. This is obvious. You should know this and be able to follow this. So at 4.30, the derivative is 0. What's a value slightly smaller than 4.30? 4.2? 4.29? So we take this function and we can enter in 4.2 or 4.29. This is smaller than 4.3. Is this value positive or negative? What's a value slightly bigger than 4.30? 4.31. Is this value positive or negative? So here in this table, we're looking at the value of the derivative before and after the point that we found. Is this a minimum or a maximum value? Is this a minimum or a maximum value? Why? Negative, 0, positive. Negative is negative gradient goes down. 0 gradient goes across, positive gradient goes up. What type of turning point is this? This is a minimum. This is a minimum. So we are showing here in step 4 that 4.3 will produce a minimum, not a maximum.
Do we have to draw that table?
This is one way of showing that the value we found will produce a minimum. Typically, these questions for you guys will be more structured questions, leading you through each part. So maybe you might have 5 parts to the question, and each one is specifically guiding you on this course. On other courses, you might just get an unstructured question. Like in an AP course, you get an unstructured question. You just be given the original question after you work this yourself. Whereas in the IB, you get structured questions. They say, do this, do this, do this, do this.
So it's taking a long
It would guide you along. It would say, find an expression for the surface area. Then it would say, find the derivative. Then it would say, find the turning points. And it would show that the value you found will produce a minimum or a maximum.
And you have to show that.
Yeah, this is one way of showing it. We did it by showing the graph. Yeah, in last class, we showed the graph and then we reasoned. But the main thing you want to be saying is the derivative goes negative, 0, positive. It's these type of statements. You can do it in a table like this one, or you can do it. You can write it. The either side of 4.3, the derivative goes negative, 0, positive. So our last step, step 5. Our last step, step 5, is to reread the question and see what it is after all this work we were actually meant to be doing. So let's go back to the question. Can of food contains 500 centimeters? The manufacturer wants to receive maximum profits, making sure the surface area can be optimal. Let the radius be r and the height. Find the dimensions of the can. So have we answered the question?
Yeah.
No, we didn't give the,
We've half answered it. What have we not found? The height. We have to find the height. I tell you to reread the question at this point because the question could be saying, what is the minimum surface area? Notice the question's not asking that. It could have been asking that. So at this point, we have to put r back into this function for height here, but we could be having to put it back into this function for surface area here, depending on what the question was asking. And usually with these longer type questions, you forget what it was that you set out to do when you set out for a longer question like this. So we have a function here that describes the height in terms of r. We can go back to this and use this. So height is 500 over pi r squared. So for 5, we can use height is equal to 500 over pi r squared. Now here on my paper, I write 3 significant figures. On my calculation, I don't. I have to use the exact values to get the accuracy points. So with the calculator, I have to do my quotient 500. Right, let me just stretch that. My window's gone a bit small. Yeah, that's my 500 over pi times. Now we need that number squared. Where was it? You go up there to that number. That's the exact value. Oof. All right. So I'm having difficulty getting it in the place I want it to go. So I'll go up, copy this number down, and press Control Store. I'll put it in the letter R. Great. So this time I can do 500 over pi times r squared. 8.60. This is equal to 8.60. So notice here, I took care to use the exact value. The exact value. You can often see this in the mark schemes when I hand the mark schemes to you for a course. So when we're looking at our last major, when we're looking at the last major here, notice here in this bit, the answer there is 4.62, but it's not showing 4.62 in the numerator here. It's showing 4.61944 dot dot dot. This is implying that you must be using the exact value, not the rounded 3 significant figure value given here. Okay. So we use our exact value, we're finished. All right. You need to have a go at question 12F now. The first question is easy. The question I just did was more complex. It was challenged. I could see that for you guys. The first question is an easier shape, and you should manage